Hi everyone, welcome back to this coding series. In this exercise, we'll learn how to add custom logic using handlers in an SAP CAP project. So we'll create a bookshop project where we modify book data before it's saved to the database using custom logic. And basically, we're here using a before handler, and it's a beginner level coding practice. In SAP, handlers can be attached to a specific lifecycle events of an entity using hooks. The common hooks are on, before, and after. On hook is triggered when a specific event like read, create, update, and delete is executed. So it is used to perform custom logic when an event is triggered. Before hook is triggered when the event is executed. So before the event is executed. So it is used for validation or modification in input data. And finally, after hook is triggered after the event is executed. Generally, it is used to modify the result after it's fetched or saved. So let us walk through the steps of our demo project today. Step 1 we'll start by creating a new CAP project using the CDS initialize command and install the dependencies with npm install. Second step, we'll define a data model in a .cds file under the database folder, create entities and fields to structure your data. And the third step, we create a service definition in the SRV folder and expose the CDS entity. And the step 4 will be implementing custom business logic in a JavaScript file using event handlers like before and on. So here we are specifically focusing on the before hook. Step 5. So we will create a sample data. We will use a .csv file and we place it under the database folder and the data folder and populate with sample data. Finally, we'll run the project and test it using a client. Let us jump into the Visual Studio or the Bash tool and start implementing. I'm using Visual Studio here in this video and the steps remain same for Bash tool as well. Let us get started. First step. So we'll open your terminal and create a new project using the following commands: cds init and initialize. We'll keep it as bookshop. So basically it will create a folder with the name bookshop and the necessary structure of the folders required. So as you can see here, the bookshop is created and the necessary application, database and SRE folder is created. In application, we generally create our theory app. On a database, we place our database files. SRE will create our service request files and the package JSON file. Once the basic CAP project setup is completed, we will change the directory to bookshop. So once the directory is updated to bookshop, we can start creating our application. So the next step 2 will be to create a data model. So by defining a new entity books, so I'll create a new file under data folder schema.cds and I'll declare my entity. Before declaring entity, we declare namespace. So namespace, let it be bookshop. And let us define our entity books, key field as id of type uuid, title of type string, author of type string, price of type decimal. So once it is defined, we have defined an entity with the books with the key field as id, title, author and price. Let us run cds add data. so that the CSV file is created automatically by the framework. You can see here, creating the CSV file under the data DB folder under the folder data. You can see it, it is automatically created. So we'll add some test data here. IDC 12345, title, book 1, author 1, price 100. So next book. So basically some test data for testing our application. So once we add CDS, add data. So a fold CSV file will be created with the by the framework itself with the necessary naming convention, and we can add the test data here. So our entity is ready and the required test data is ready for this entity. Next, let us go to step 3. We'll create a service to expose this entity. So under SRV folder, we'll create file catalog service.cds using a, so we'll project schema. So namespace as alias name, let it be as DB. So entity projection. So our entity is books from db dot books. Sorry, first we have to create a service, let it be as catalog service, and under that service we are projecting our entity books. Just a minute. Yeah. So let us run CDS watch once. So artifact namespace has not been found. So namespace, what is sorry, it is bookshop. Sorry, I have to put it as bookshop, and it is up and ready. So you can see it. So let us stop this service and let us implement the custom logic. So basically we have created a service file, and this will make the books entity available through an OData service. Step 4. So we'll be adding a custom logic under handlers. For this, under CSV folder, we create a new file catalog dash service dot js file. Now we'll start implementing the custom logic under this file. First constant cds equal to required, we need this package. Next module dot exports equal to srv arrow function. So first we'll get our structure, that is entity books is equal to srv dot entities. So we'll create a before service. So before create on the entity books, please perform this arrow function for the request data. That is the analogy behind this statement. So before creating a book on the books entity, for the required data, so the request data will be present in the REQ. So the the custom logic will be handled under this. So here basically once we receive the data from the front end, we'll check if the data is valid or not. So here we'll consider the price field. If the price is negative, we'll update it as 0 in the database field, and we'll inform the front end saying the negative price. So if the front end data request dot data dot price is less than 0, so we'll update it as 0 itself, 0, and inform the front end saying that, hey buddy, negative price detected. So we are setting it to 0. So that's how we handled the create function. Now let us implement the same for update as well. So it is update books. So this is how custom logic is implemented. So here basically in this service catalog.js file, this handler checks the price field before creating or updating a book. If the price is negative, it automatically sets to 0 and logs a message. Next, step 5 is adding sample data, which I have done it already. Next, step 6 will be run and test. Let us start the server with CDS watch. So it is running fine. So for testing our data, we need a HTTP request file. So we'll create a request.http file under bookshop folder, and we'll pass our raw data queries. First, we'll fetch all our book details present in our server. So first, get the URL, path, and the cat entity books. Send request. See, the raw data request has been sent, and it is executed fine, and the 3 books in our database. So our code is working perfectly fine. Now let us create a new record and check whether the new record is getting created or not. For this, we create a post request. First, let me copy this JSON structure for passing the post request. Triple hash post. Okay, first let us get this. So post for this URL. Content type is application JSON. And this is the structure I need for passing. So let me give it as 1, 2, 4, 6 here. Book 6, author 6. And first let us send the price as 11, which is a positive value. Ideally it should accept. Okay. Send request. See, the post call has been executed by our data and it is created. So the new book is created. So the number of records should be 4. So 1, 2, 3, and 4. So this is the book we have created. Now let us create one more book with negative value. So now the basically system has to set the price to 0 and shows an error saying that negative price detected. See, the price has been set as 0 and it is created with the price 0, and the negative price is detected and setting it to 0. So our next, let us put for the update request. So for the same request, let me pass a patch request for. So for the patch request, I have to pass the book ID, which is equal to this one, So let me use the same ID and let me remove this. This is not required. So I'm updating a positive value, so it should update correctly. So now it is 0, it should update as 10. So let me send the request. See, it is updated successfully. And let me check in the database as well. It is C12347, C12347, and the price is 10. Now let us modify the same request with negative value and send the request. See, it is updated with price as 0, and console has been updated saying that negative price detected, setting it 0. So our code is working fine. So basically the price should be saved as 0, and you can see a log message in the console. If the price is negative, it's automatically set to 0. The log message confirms that the handler worked correctly. That's it, guys. We have successfully added custom logic using before handlers in an SAP CAP project. This helps keep data consistent and avoids invalid entries. Finally, to conclude, whenever an event is triggered on an entity, we can implement the custom logic using 3 hooks. That is on, before, and after. We use before for input validation and pre-processing of the data, and on for handling custom event logic, and after for formatting and enhancing the response. With this, let's wind up today's session. Thank you. We'll meet in the next session. Thank you, guys.